For this problem, we're going to find the measure of our angle theta here. We are given a radius, that's 5 inches, and we are also given that the intercepted arc is 9 inches. That's the distance from where each of these radii intersect our circle. To do this, we're going to use our formula S. The arc length is equal to r times theta. Remember that theta in this formula is in radians. So when we calculate theta here, it will automatically be in radians for us, and then we'll convert that into degrees at the end. So let's plug in what we know. S is our intercepted arc, that is 9 inches. R, that's our radius, that's 5 inches. So to solve that equation, we would just need to divide both sides by 5. So our answer is that theta is equal to the fraction 9/5. Usually when we come up with our answer in radians, we are going to have a pi in here somewhere, and sometimes that just doesn't happen. You don't have to have pi in your answer to have a radian measure, but often there is. So 9/5 is perfectly fine, perfectly acceptable for an answer on this. We also need to come up with this same angle but in degree measure instead. So to convert from 9/5 radians into degrees, I'm going to take my 9/5 radians and I'm going to multiply that by a fraction. We're converting into degrees, so I want that in the top. And the fraction that we use when we do our converting back and forth between degrees and radians is 180 degrees and pi radians. Those are the values we use. So I'm ready to go through and essentially type this into my calculator. We have a radian in the top and the bottom, so the units of radian technically would cancel. In my next step, what I have, if we went through and showed an extra step of work, we have 9 times 180 in the top. That is 1,620. Down in the bottom I have 5 pi. So to convert this into degrees, I'm just going to do 1620 divided by the quantity 5 pi. So I'm going to put that in parentheses because I want to divide it by the entire 5 pi. And if I do that, I get 103 with a decimal after that. We're going to round these off to 1 decimal place. So this is approximately equal to 103.1 degrees. We were supposed to come up with 2 answers here. One was the measure of our angle in radians, and then the other is in degrees.